There are other ways to, there's modifications of the Bonferroni called the Holm and Hochberg, which are a little bit less conservative. There are other procedures for adjusting the p-values to reflect the number of multiple tests. Those are called Tukey and Chaffee. And again, usually you can just ask the computer to apply those various corrections if you want to go in and figure out exactly where the differences lie after doing a global ANOVA test. Now I'm going to say a little bit about repeated measures ANOVA. You use repeated measures ANOVA when you've got either more than 2 correlated groups, or you've got you're following people over more than 2 time points. So there's correlation here. Here's an example of a study that used repeated measures ANOVA to analyze the data. This was looking at a placebo pill versus a particular treatment for depression. The outcome here is the depression on a certain scale. They're following the 2 groups. These are 2 independent groups over time. And they want to know, did the placebo group go down less over time than the treatment group? It does look like there's a placebo effect here. Both groups have an initial improvement in depression, but only the active treatment group keeps going down in depression scores. The p-value here of 0.0002 that you see comes from a repeated measures ANOVA. I'm not going to go much into the details of how the repeated measures ANOVA works, but that would be the appropriate statistical test when you're following people over time like this. We have multiple time points, so a paired t-test will not suffice. We need instead repeated measures ANOVA. So how did I figure out that I needed a repeated measures ANOVA? The statistical question here is, do the subjects in the treatment group have greater reductions in depression scores over time than those in the control group? My outcome variable is depression score. That is a continuous variable, and it is a normally distributed variable, or my sample size here is large enough that it doesn't matter. Are the observations correlated? Yes, I have multiple measurements, many measurements on each person, so I have correlated observations. I have more than 2 time points, so a paired t-test will not suffice. I'm going to have to use a repeated measures ANOVA. I also have multiple groups here, which paired t-test only is going to work on 1 group over time, so I need to use repeated measures ANOVA because I have multiple groups and more than 2 time points. Again, I'm not going to go into much detail about the repeated measures ANOVA. I'm just going to tell you a little bit about it and how it works and when it's used. Again, if you need to have more than 2 time periods, paired t-test is not going to suffice. Now you could say, well, why don't I just do multiple paired t-tests, right? I could compare time 1 to baseline. I could compare time 2 to baseline. I could compare time 3 to baseline. I could use a paired t-test to do for each of those comparisons. But again, the problem is that's going to increase your type 1 error, your chances of a false positive. So we don't like to do a whole bunch of paired t-tests. We'd rather put everything together in one global test, which is repeated measures ANOVA. And it answers the following questions. You get a couple of things out of repeated measures ANOVA. So if you've got, say, 2 groups or more than 2 groups that you're comparing over multiple time points, it can answer the following questions. First of all, it can answer just whether or not there are significant differences across time periods. Does your outcome change at all across time periods? So that's the time factor in repeated measures ANOVA. You can also ask whether or not there are any significant differences between your groups if you've got multiple groups that you're comparing over time. And you can ask whether or not there are significant differences in the changes over time between those groups. So you have what is called a time effect, a group effect, and a group by time effect. And usually what we care about, like in that depression example I just showed you, we cared about the group by time effect. We cared whether or not there were differences in the changes in depression over time between the groups. And repeated measures ANOVA can answer that question for you. It's very good for longitudinal data. So to ask, is there any change at all over time in any of the groups? That's the time factor. If you want to ask if there's any differences in the groups at any time points, that's what we call the group factor. But the one we really care about is whether or not the 2 groups differ in their responses over time. That's what we call in repeated measures ANOVA the group by time factor. And I'm just going to show you a couple of different examples of some mock data to give you a sense of what you get out of repeated measures ANOVA. So these are all examples where I've got 2 groups and I'm following them over multiple time points. Call them group A and group B. So you can just look at this graphic, and what you see in this graphic, this is a mock made up data, but group A seems to be going down at a faster rate, and this is, let's say this is depression score. Group A, which is in black there, seems to be going down at a faster rate than group B. Group B is actually pretty steady. It doesn't change too much. It's pretty stable over time. So it looks like the time factor For this repeated measures ANOVA, we're going to get a time factor. That time factor is statistically significant because overall, if you just ignore group, overall there does seem to be some change over time. Overall there seems to be, on average, there seems to be some decrease in time. The group by time factor is significant here as well because the two groups definitely differ in what happens over time. One group goes down in depression, the other is stable. The group factor is not significant here. We usually care least about the group factor, but overall, if you just kind of average the depression across all the time points in group A versus group B, that was about the same because group A starts a little higher but ends a little lower. So the group factor here will not come out to be significant. Here's a picture where time is not significant. Nobody's changing over time. Everybody's stable, so time is not significant. Group by time is also not significant. Both of those lines are essentially pretty parallel. The changes over time are the same for both groups. However, the group factor here would be significant because at all time points, group B is higher than group A. One final example. Here's an example where time would be significant. Everybody's going down over time. Group is not significant because the two groups on average seem about the same. And group by time also does not come out to be significant because both groups, those lines aren't perfectly parallel, but both groups are going down. The group A is going down slightly faster than group B, but not enough to achieve a statistically significant difference in the slopes there. So that's the basics of repeated measures ANOVA. Of course, there's a lot more to repeated measures ANOVA, but that will just give you a flavor for that technique that's out there for these kinds of longitudinal studies.